Hello friends, class 10th, chapter 1 chemical reactions and equations. Wait. Don't be hurry, which creates confusion. Don't even worry, which destroys your peace. Let us stay focused and stay calm and complete this chapter in a single stretch video, which is my flowchart targeting the board exam 2027 in a simple way. Before I start with this chapter, I'll go with the different questions that come in the previous exams and also some expected sample questions. According to the questions, let us learn each and every topic in an easy way. For that, let me have a simple question on the board here. That is, the blue color copper sulfate crystals turn white on heating. On adding water, the blue color reappears. A student says this is a chemical change because color changed. Do you agree? Give reason. So the thing mainly observed by the student here is change in the color happened. And when it comes to another example here, another question here, iodine crystals on heating form purple vapors, on cooling crystals formed again. So in this case, change in the physical state happened. So what about these two changes? Are these chemical changes or physical changes? In our earlier classes, we have learnt about the changes. In a simple way, we have studied that usually the change which is reversible was called as physical change. The change which is irreversible was called as chemical change. The chemical change, otherwise called as a chemical reaction, if you look here, in every chemical reaction, we find some observable changes. Those observable changes are usually called as indicators of a chemical reaction or chemical reaction indicators. There are different kind of indicators during a chemical change or a chemical reaction. Let us see each of those indicators one by one. For example, let us consider the most familiar activity we have been learning, the iron nail placed in the blue color copper sulfate solution. After some time, the solution turned into green color and some brown deposit will be occurred over the iron nail. This is the best example for a kind of chemical change. Why? Because we observed here change in the color happens from blue to green. That is due to the formation of blue color, changed to green color, where the copper sulfate changed to iron sulfate. So this is one of the indicators of a chemical reaction or chemical change. Means whenever we see change in the color in a change, yes, we may think that it is a chemical change. In the same way, let us consider here evolution of gas. This is an example where the zinc granules are reacting with hydrochloric acid to liberate, to evolve hydrogen gas, a colorless gas which makes pop sound with a burning flame, sprinter. So we confirmed that the gas evolved as hydrogen gas. So the evolution of gas is also an indicator of a chemical change. Another one, two solutions are added to each other here. Say lead nitrate solution is added to potassium iodide solution. So we got an insoluble product here. That insoluble product which is formed is called a precipitate, and that occurs here in this case in yellow color. That yellow color precipitate is formed lead iodide. So formation of precipitate is an example of, is an indicator of a chemical change or chemical reaction. Take another, change in the temperature. Suppose if you look at this reaction, see the best example, very familiar example, quicklime. That is calcium oxide, when added in water, the container becomes hot. That is because during this reaction, during this change, some heat is liberated. Due to the release of heat, the temperature of the container increases, where we consider that change in the temperature as an indicator of a chemical reaction or chemical change. Now coming to another, change in the state, as this is an example. For example, like see, another familiar example, the carbon powder, if burnt in the presence of oxygen, turns to carbon dioxide, where this is the solid, this is the gas, and the carbon dioxide formed is also a gas. So change in the physical state happens during this particular change. So change in the physical state is also an indicator of a chemical reaction. At last, change in the smell, that is change in the odor, is also an example of an indicator in a chemical reaction. See, usually these are the examples like milk setting into curd, or the food which is spoiled becomes some kind of odd smell, rotten smell. That change in the smell or odor also an indicator of a chemical change. So now the question comes here. In the beginning questions, we have seen that change in the color happened, change in the physical state happened. So that by seeing those changes, by seeing those indicators, can we confirm those changes as chemical changes? Absolutely not. Just by seeing the indicators, you cannot confirm a given change as a chemical change. Why? Because if you look at this table, it simply conveys. See, for example, change in the color is an indicator of a chemical change, that is chemical reaction. Actually, this change in the color may also be seen in a physical change. The examples are given here, like mixing of different kind of dyes, that is colors, and heating a metal until it glows. When you take an iron rod and you start heating it, it gives you different colors. So change in the color happened here, but it is not a chemical change. So the point you have to keep in mind is, when you see change in the color, do not confirm that change as a chemical change. Why? Because change in the color may also happen in the physical change. In the same way, evolution of gas occurs during a chemical change. In fact, it may occur during a physical change. So that's why this is also not 100% proof or indicator to say a particular change as a chemical change. Now coming to formation of precipitates. Yes, maybe here we have to stop somewhere and consider this point. Why? Because formation of precipitate is nothing but an insoluble product is formed where we were mixing the two solutions. So it will happen in the chemical change, it is an indicator, but mostly it will not happen in the physical change. So as per our grade 10, as per our standard, whenever you see a precipitate is formed in a chemical, in a reaction or in a change, you can confirm it as a chemical change. So you can depend on the formation of precipitates. This is the most reliable hint where you can confirm a given change as a chemical change, but you cannot depend on any other indicators. Why? Because even change in the temperature, change in the state, change in the smell, these may happen in a chemical change, and in fact these may happen in even physical change as well. So finally, before you confirm a change as a chemical change, you should not depend simply on the indicator. You have to depend on the important point, formation of new substance. When the new substance is formed, it is a chemical change, and the indicators are additional hints or the clues to help you in identifying the chemical change. Now, finally, we got to the chemical change or chemical reaction, where we have reactants and the products. Usually, to represent a chemical reaction, the shortest form is a chemical equation. But the thing is, when you are going to have the chemical equation must be balanced. So the balancing of chemical equations is mandatory. Why balancing of chemical equations is mandatory? You know very well. Just the simplest point, to follow law of conservation of mass. This is the simple law where it says mass or the matter or the atoms neither be created nor destroyed during a chemical reaction. That's why the number of atoms participating in a reaction, that is reactant side, must be equal to the number of atoms product side. That is the simple point. It means whenever you got the question, what is the need of balancing a chemical equation? Just simple point, to follow the law of conservation of mass. Why? What the law of conservation of mass is saying? The number of atoms reactant side must be equal to number of atoms product side. To balance the chemical equation, the most common conventional method is absolutely the trial and error method. The problem with the trial and error method is, it is a method where we are going with random guessing, just trial. Obviously, the random guessing leads to confusion. To simply avoid this confusion, I brought here a simple method where we can balance any chemical equation easily with a method called algebraic method. This is the simplest method of balancing the chemical equations in just simple 5 steps. Let's see each of those steps in an easy way. First step in balancing the chemical equation using the algebraic method is writing the skeletal equation. What is the skeletal equation? Just as per the statement of reaction or as per the equation given readily, if we just write the reactants and products on the either sides, then it is the skeletal equation. Before I start with next step, we need to understand about some numbers involved in the equations. There are two kinds of numbers will be present in the chemical equations. The first type of numbers we call as coefficient. The second kind of number, subscript. Simple. In this equation, let us try to understand what is a subscript first. If we look at the formulas of different compounds here, suppose number 2 is at right hand side bottom for the hydrogen atom. This number usually called as subscript for hydrogen. Suppose the 4 is the number which is at right hand side bottom of the oxygen, and that is the subscript for oxygen. In the same way, 3 is the subscript for iron atom and 2 is the subscript for only hydrogen atom in this water molecule. Suppose I have taken A in front of iron. If you look at the iron atom in the reactant side, there is no subscript. That means the subscript for the iron is 1. And I have written a number, of course it is unknown, exactly we don't know its value. I have written in front of the iron atom. So the number which is preceding the formula or symbol, which is in front of the formula or symbol, is called coefficient. Simple. Suppose I want total number of iron atoms, reactant side. Simple. If you want total number of atoms anywhere, just do simple thing. Multiply coefficient of an atom with it's a subscript that will give you the total number of atoms particularly. Suppose the coefficient for iron is A here, the subscript for iron is 1. So A into 1, that is 1A is the total number of iron atoms reactant side. In the same way, we can count the total number of atoms in any case. Now the second step in the algebraic method, assigning the variables. Sir, what is assigning variables here? Simple. In balancing the equations, as we know already, we never change the subscript. Subscript never be changed. We can change only coefficient. Only coefficient can be changed, but no subscript can be changed. So, since we exactly don't know what coefficient is suitable here, what is the number suitable here, let us assume A, B, C, D. These are the coefficients for each reactant and product. These A, B, C, D are the variables now because we don't exactly know their value. Now, once we assign the variables for each reactant and product individually, in the third step, let us make some equations. We call them as algebraic equations. So how to make the algebraic equations? How to write them? Simple. Just consider any of the atoms. Say iron atom, as I have done in the earlier case. In the reactant side, iron atom has the coefficient A, and since we have nothing here, the subscript is 1. So the number of iron atom reactant side will be A into 1. Come to product side, the coefficient for iron atom is C and its subscript is 3. So I will multiply the C with 3, which will give me the total number of iron atoms. Since we assumed it a balanced equation, number of atoms left side must be equal to number of atoms right side, product side. So these are equal to each other. So I got an equation here that is 1A is equals to 3C. Keep the algebraic equation aside. Now, using oxygen, let's write one more algebraic equation. Take the oxygen reactant side. What is the coefficient? B. Since nothing is here, its subscript is 1. Go to product side. The subscript for the oxygen is 4 and its coefficient is C. So C into 4 will give the total number of oxygen atoms product side. Now these both are equal. As I told, this is a balanced equation. So finally, what we get? 1B is equals to 4C. Keep it aside. Now coming to another atom called hydrogen. If you look reactant side, B is the coefficient and 2 is the subscript for hydrogen. Product side, D is the coefficient and the same 2 is the subscript. Since both are equal, we can cancel the 2 either sides. So finally, we got the relation B is equal to D. So we got 3 algebraic equations here. Let's go with the next step now. Finding the values of these variables using the LCM method. This is a simple method and this is a crucial. In this algebraic equation, 1B is equals to 4C. So we have the two numbers here, that is 1 and 4. What is the LCM of 1 and 4? 4 we know very well. Now simply 1B must be equal to 4 and 4C must be equal to 4 as per the equation. So from this, I can simply find B is equal to 4 by 1, which is equals to 4, and from this relation C is equals to 4 by 4, which can be cancelled, and C is equal to 1. From this algebraic equation, 1 and 3 are there numbers here? LCM of these two numbers will be 3. Then we can write the 1A is equals to 3. 3C is equals to 3. So from this also we can find the value of A as 3. 3 by 1, that is 3. And C is equals to 3 by 3, which is equals to 1, as we got already. So we got the value of B 4. From that equation B equals to D, that's why we can write the value of D as 4. So now if you look at the all calculations, we got the value of A, that is 4, got the value of B, sorry, A value is 3, B value is 4, C value is 1, and obviously the D value is 4. Now just plugging these values in the equation will give you the finally balanced equation. See here, value of A we got as 3, B is equals to 4, C equals to 1, D equals to 4. The 1 you can write or even you can omit it. So this is a finally balanced equation in a simple method. You can use this method for any kind of chemical equation. Just little care must be taken while calculating the values of variables. So there are simple 5 steps. What are those? Writing the skeletal equation, first step, assigning the variables, writing the algebraic equation, finding the values of variables with the LCM method, and finally writing the balanced chemical equation. Still, okay, this algebraic method is confusing. For example, sir, unable to do some calculations. Sometimes he may ask about balancing of chemical equations step by step. He may ask you trial and error method only. Why? Sometimes the algebraic method you can use where he is asking you directly balanced equation, or where he is asking you just to give the coefficient of some product or some reactant. But if he is asking you step by step, sir, then what to do? There are few other techniques, few other shortcuts or tricks to balance the chemical equations. Let us try to explore them. So the simple, if you want to go with the trial and error method, the first suggestion, the first trick you have to follow is simple. Always balance complex molecule first. For example, in this equation, alumina, that is aluminium oxide, hydrochloric acid, aluminium chloride, and water. And look at the equation here, KClO3, KCl, and O2. In these equations, these look like complex molecules, means more number of atoms are there. So you can start with those molecules to balance the equation, which will be easy for you. You can try it and put it in the comment if you have any difficulty with any equation. Next, another simple hint I am giving you, always follow MnHO order. That is, in any chemical equation, first try to balance the metals. That will be easy. Then go with non-metal. Then hydrogen, balance the oxygen atom at last. Because in most of the equations, oxygen will be a diatomic molecule somewhere, either reactant side or product side or somewhere. So sometimes when you balance metals and non-metals, automatically hydrogens and oxygen atom automatically balanced, sometimes, not always. So that's why start with metals, then non-metal, then go with hydrogen, at the end oxygen. You can try these equations on the board. Now this is the simplest shortcut method I would like to tell you, but it is applicable only for this kind of reactions, this kind of equations, where, so simple condition, the condition is very simple one. You look here, oxygen atoms, balancing the oxygen atoms will balance almost equation here. But the condition is, look here, oxygen atoms, number of oxygen atoms odd in number, product side, one side, another side, number of oxygen atoms even. Then what to do, sir? Just multiply. What to multiply? So simple, the multiplication is Just bring the number 3 here and put it here. Bring the number 2 and put it here. Now 3 into 6 oxygens are balanced. 2 into 3, 6 oxygens are balanced. Now 2 into 2, 4, and this is a 4. So in a simple way, you can balance this. Same technique can be applied everywhere. So look here, oxygen atoms are 5, odd number. Oxygen atoms are 2, even number. Just bring the 5 here and bring the 2 here. Oxygens are balanced. Even automatically in this equation, even phosphorus is also balanced. Look for another equation here, same concept, odd even shortcut. Bring the odd number here and keep the even number here, equation will be balanced. This is the simplest shortcut, which we say as odd even shortcut. This is usually applicable where an atom must be even one side, odd another side. Now, an important shortcut I brought here. This is the most useful trick. You might have found these kind of equations. Like, look here. Here, this is pentane. This is ethane. They are undergoing combustion, that is burning in the presence of oxygen. So how to balance this? Of course, algebraic method, trial and error method, complex molecule technique, odd even shortcut, different kind of techniques are there. But here, you can use a simple formula. Using that simple formula, you can balance the equation easily. So, C5H12, look here, assume this number as X. Assume the subscript for hydrogen as Y. Then as per the formula, X should be kept here, that is 5, because 5 is the subscript for carbon. 12 is the subscript for hydrogen, right? So, which is treated as Y. Y by 2, that is 6 by 2, 12 by 2 is equal to 6. Now, product side, it is balanced. We need coefficient for oxygen. To calculate the coefficient for oxygen, use this formula. What is the value of X here? 5. What is the value of Y here? 12 divided by 4. What to do? 4 3s are 12. Then you get the value 8. Then keep the value 8 here. That will be the balanced equation. So simply you can match it. Number of oxygen atoms 16 here. So 5 2s are 10, 6 1s are 16. 6 totally equation is balanced. Now let's look at the equation. Ethane undergoing combustion to form carbon dioxide and water. In this, X value is 2, Y value is 6. In that case, here it will be X, that is 2, and here it will be using the formula Y by 2, 6 by 2 is equals to 3. Now, as per the formula, we need to find the coefficient for oxygen. What's the formula here? X plus Y by 4. As per the equation, the value of X is 2, the value of Y is 6, and divided by 4. So, if you calculate it further, 2 4s are 8, 8 plus 6 by 4, that is 14 by 4. So, 14 by 4 is the coefficient. So, in this case, if you want this equation a little changed, then you cannot leave fractions as coefficients. Just to make them round figures, you can multiply the equation with any number. For example, I got this whole equation. I will multiply this whole equation with number 2. Let's see what happens. Then that equation will become C2H6 plus 14 into 4 into 2 O2 gives rise to 2 into 2 4 CO2 plus 2 into 3 6 H2O. So here what happens? Obviously 4 and 2 cancels, then 2 is here and 2 sevens are 14. So that the finally balanced equation will become 2C2H6 plus 7O2 gives rise to 4CO2 plus 6 H2O. So this is a method simply we can apply. That means whenever using the formula, if any coefficient is not a normal number, if you got it in a fraction, then automatically multiply the whole equation with certain number by which you can get the simplest possible ratio. Now a small change, if you look here, for example, earlier we have seen the combustion reaction of alkanes, alkenes, alkynes. For example, if you have the combustion of alcohols and carboxylic acids, then what happened? You can make the change in the formula in a simple way. Now look at the formula here. An additional atom arrives here, that is oxygen, because the alcohols and carboxylic acids contain additional oxygen in the compound. So assume the X as the number of carbon atoms, Y as the number of hydrogen atoms. Don't just consider this subscript only, you have to add this one as well. And Z is the number of oxygen atoms in the alcohol or in the carboxylic acid. Now as per this equation, can you tell me X, that is number of carbon atoms, is 2, Y, that is number of hydrogen atoms, 5 plus 1, that is 6, number of oxygen atoms, that is Z value, is 1. Now using this hint equation, we can balance this chemical equation easily. So what is there again? Same formula. X will be the coefficient of carbon dioxide, that is, look here, X value I have written directly. Once again, Y by 2 comes here. What is the Y value? 6. 6 by 2 is equal to 3. Then what about the coefficient for oxygen? You have to go with this formula. So let us try to calculate it. X equals to 2 plus, what's the Y value? That is 6 by 4, that minus, what is the Z value? 1, and divided by 2. When you calculate this, you will get the answer here. Let's simplify it. 6 by 4 will be equal to 3 by 2, that is minus 1 by 2, which will be equal to 3 by 2 minus 1 by 2 will become 2 minus 1 by, 3 minus 1 by 2, which is equal to 2 plus 2 by 2, which is equals to 1, that is 2 plus 1, which is equals to 3. So the value of coefficient for oxygen is 3. So that equation is balanced. Now let us apply this formula to the combustion of acetic acid, that is ethanoic acid. Now from this equation, what is the value of X? As I told you, the value of X is the number of carbon atoms. So one carbon atom is here, one carbon atom is here. So that X value is 2. Y value is the number of hydrogen atoms. 3 hydrogens are here, 1 hydrogen is here. So the number of hydrogen atoms is 4. Z value is the number of oxygen atoms. 2 oxygen atoms are here. As per the formula, directly you can plug the X value here, that is 2, and Y by 2 here. What is the Y value? 4. So 4 by 2 will give you the 2. Now let us find the coefficient for oxygen in reactant side. Once again, what's the formula? X value is 2 plus, what's the Y value? 4. So 4 by 4. What is the Z value? that is 2 by 2, because x plus y by 4 minus z by 2. So obviously these will be cancelled, and what else? 2 plus 1 minus 1, plus 1 minus 1 cancel, the value remains is 2. So the 2 is the coefficient for oxygen in this equation, which is balanced. So this is the simplest method to balance the equations. Especially these formulas are applicable to combustion reactions. This is a formula applicable to the combustion of alcohols and carboxylic acids, and the earlier one, this is a formula which is applicable to the combustion of alkanes, alkenes and alkynes. This is another method, use fraction, which we have already done. Now usually in trial and error method, this is a small hint. Whenever you are trying to balance the equations which are having polyatomic ions, that is complex ions, just if possible, if they don't change from reactant side to product side, just treat them as a single unit so you can balance them easily. For example, see, sulfate here and sulfate is here. So instead of balancing the sulfur and oxygen separately, these, you can directly balance the sulfate, check the number of sulfates left side and right side. And in this equation, carbonate, nitrate here. So in this equation, carbonate cannot be considered. Nitrate can be considered. Why? Because the nitrate reactant side carried forward to the product side as it is. Whereas here the carbonate in the form of CO3 changed into carbon dioxide when it comes to product side. So that's why in this equation, you can treat the nitrate as polyatomic ion as a single unit, but you cannot treat the CO3 because no CO3 right side. In such a way, look at the different kind of polyatomic ions, treat them as a single unit, and you can balance the equation easily. What are the common mistakes usually in balancing the equation? When people are balancing the equation, knowingly or unknowingly, usually out of confusion, out of curiosity, in a hurry, we may commit some mistakes. Very silly, but must be addressed in our mind to avoid the mistakes. See, change the subscripts instead of coefficient. This is the most common mistake many people do in the earlier stage, in a starting stage of balancing the equations, but don't do ever. Why? Because changing the subscript will change the nature of the substance, whereas changing the coefficient will change only the number of atoms. I'm not going much deep into that. Now, as I told you already, we have to start with the metal, then balance the non-metal, then go with hydrogen, then at the end balance the oxygen. But don't start with the hydrogen and oxygen in the beginning, because you have to keep on changing their number if you start with them. Definitely do not ignore the polyatomic ions. If you find polyatomic ions which are same on the either sides of the reaction, just treat them as a single unit and balance it. Definitely, sometimes when you are going with the trial and error method, don't be hurry. As I told you, count the all atoms equally. And charges in ionic equations, mostly you are not getting these ionic equations, but if you get ionic equations, considering the charge also very important. And this is another common mistake, symbol of elements. Do not forget the difference between whether is it an element or a compound. For example, see here, CO, 6CO. Don't think that this is carbon and this is oxygen. This is actually cobalt. So to find the difference, this is the symbol of cobalt, as you know, and this is the carbon monoxide. Okay, just be careful while dealing with the elements and compounds where their symbols and formulas look similar. Now, here is an interesting question. Let's try to understand them. A white solid is heated and a gas is evolved. The solid left behind is also white. Which equation correctly represents the physical states? Sometimes just balancing equations is not enough. He is asking such kind of questions to tell about the physical states. See, he mentioned already a white solid is heated and a gas is evolved. The solid left behind is also a white. In the question itself, he is addressing a white solid, that is reactant is a solid. So check for the options. S indicates solid here, so this is the correct option. And automatically a white solid remains even after the evolution of gas. Definitely the colorless gas or the gas which is evolved might be carbon dioxide, and the white solid left is the calcium oxide quicklime, right? So this is the correct option. Sir, how to remember these physical states of the reactants and products? I have brought few of the shortcuts, some common points we need to remember to identify the physical states of the different reactants and products easily. So everybody knows, whenever you see a metal, only metal, not metal compound, whenever you find a metal, for example iron, simply calcium, magnesium, sodium, just potassium, etc. Whenever you see a metal alone, yes, definitely you can mention the physical state of the metal as solid, and except for mercury, as you know, which is the only liquid metal. Now coming to non-metals, all non-metals, look here, all non-metals are gases. All non-metals are gases. But what's the difference? See, exceptions are there. Carbon is solid, sulfur, phosphorus, iodine. These are the solids. Remaining all non-metals are gases. And of course, there is a liquid non-metal as well, that is bromine. So if you see individual bromine in this way, then it must be a liquid. If you see the carbon alone, it should be solid. If you see sulfur, it should be solid. If you see phosphorus, it should be solid. If you see iodine, it should be solid. The remaining all non-metals are gases. So then what are those? Like oxygen gas, nitrogen gas, fluorine gas, chlorine gas. So these are the gases which come under non-metals. And definitely, whenever you see any acid, whenever you see any base in the equations, write them aqueous solutions, because acids and bases usually react with others in the aqueous solution form only, usually. So that's why in the chemical equations, whenever you find acids and bases, just you can mention them as aqueous solutions. Aqua here means water solutions. Any exceptions are there? Yes, of course there are some exceptions, like bases like aluminum hydroxide, ferric hydroxide, ferrous hydroxide, copper hydroxide, they appear as solids. Actually the thing is, these are insoluble in water, that's it. That's why they appear in solid form. Except these aluminum hydroxide, all are hydroxides, keep in mind. Aluminum hydroxide, iron hydroxides, and copper hydroxide. Except these hydroxides, because these are insoluble in water, every other acid, every other base is an aqueous solution in any chemical equation. That's it. Now coming to the point, salts. For example, you might have seen salts like sodium chloride, potassium chloride, magnesium chloride, sodium carbonate, etc. You see any kind of salt in any equation, yes, that is also soluble in water. That is why you can mention it as aqueous. Sir, any exceptions are there? Yes, we have seen precipitation. While we were talking about the indicators of a chemical reaction, we spoke about precipitation. So why the precipitate is formed? When a reaction happens, if any salt is insoluble in water, that insoluble salt will be separated, will settle down as a solid, which we call as the precipitate. What those are? Very familiar. Many times we have seen this example. Milky white calcium carbonate that is insoluble in water. That's why it forms milky white precipitate. And obviously, barium sulfate, silver chloride, lead chloride. These are the examples. Lead iodide as well, silver bromide as well. So these are the salts which form precipitates. That's why if you find them in any reaction, write them as precipitate. Other all salts mention as aqueous solutions because these are soluble in water, they are insoluble in water. So any salt which is soluble is write as aqueous solution. Any salt which is insoluble, it will settle down at the bottom of the container as a precipitate. So write it as a precipitate. So now coming to all carbonates except those of sodium, potassium, ammonium form precipitates in aqueous reactions. So this is the another hint here. Any carbonate, see for example here we have seen the carbonate, calcium carbonate. So if you want clarity about the carbonates, keep this point in mind, that is all the carbonates, whenever you see sodium carbonate or sodium bicarbonate, potassium carbonate, ammonium carbonate, these are soluble in water. So write them as aqueous, write these as aqueous. Other other carbonates or other bicarbonates, write them as precipitates. That's it. Now simple, all hydroxides are solids in reactions except those of sodium hydroxide, potassium hydroxide, calcium hydroxide and barium hydroxide. As we have said already there in the reaction, all are precipitates, all are solids actually. Then which hydroxides are soluble, sir? Whenever you see sodium hydroxide, potassium hydroxide, ammonium hydroxide, calcium hydroxide, barium hydroxide, these are aqueous. Any other hydroxide is a precipitate. Simple point. Now coming to sulfates, we are talking about sulfates. Barium sulfate, lead sulfate, calcium sulfate are insoluble and form precipitates. Just now we have seen in the earlier case. All other sulfates are soluble and appear as aqueous solutions. Keep the point in mind, you can note it down. All the sulfates are aqueous solutions. What are the exceptions? Lead sulfate, barium sulfate, calcium sulfate. These are the precipitates. All the remaining sulfates are aqueous solutions because they are soluble in water. Now coming to the point, as we told, this is the points which are being repeated here. Silver chloride, silver bromide, silver iodide, lead chloride. These are precipitates as we said already. Remaining halides are soluble in water, aqueous. That is, as we said, no, sodium chloride, potassium chloride, sodium bromide, potassium iodide, all they are soluble in water. So we can write them as aqueous solutions. Which halides should be written as precipitates? Silver chloride, silver bromide, silver iodide, as I told earlier, and lead chloride. These are the precipitates. The remaining, all the halides are the aqueous solutions because they are soluble in water. So this is a way how to identify the physical states of the reactants and products in a given chemical equation, usually to make the chemical equation more informative. Yes. Now, till now we have been talking about what is a chemical reaction. and indicators of a chemical reaction, what's a chemical equation, what is the need to balance the equation, and we have seen the different kind of steps, tricks to balance the chemical equation. Now this is the tricky question on the board. Identify the type of each of the following reactions, stating the reason for your answer. Look here, iron oxide reacting with aluminium, giving aluminium oxide, iron plus heat. Lead nitrate reacting with potassium iodide, lead iodide is formed, and potassium nitrate. By looking at equations, what do you understand? See, maybe for this one, how to give, what kind of type of reaction is this? So to answer these questions, for example, we have another question on the board. Define the term decomposition reaction, write one chemical equation each for the decomposition reaction where energy is supplied in the form of heat, light, or electricity. Decomposition of vegetable matter into compost is considered as an exothermic reaction. Why? To answer all these kind of questions, you cannot answer these questions in a simple word or with a simple one word or one line answer. Usually, these kind of questions may have multiple answers. How? Let us see. For that, let's have a classification chart or table where the chemical reactions are classified into different types based on the different aspects as well, different points as well. See, the main types of chemical reactions. Look here. The chemical reactions are classified into different types. We say them as main types. There is another classification based on the energy changes. Chemical reactions are exothermic and endothermic type. Of course, we even have reactions in our day-to-day life like corrosion, rancidity, which will affect our life if we don't understand them and analyze them. So first of all, let us go with these main types of chemical reactions which are very important. Look at the question again here on the board. A competency style question which came in previous exam. A white powder is mixed with water. The container becomes hot and a milky solution is formed. Identify. He's asking 3 questions based on the statement he gave. One is, he's asking to identify the type of reaction and also asking to name the white powder, what he has taken initially. Just guess. And what's the reason for the production of heat? Look here, another question. During the burning of magnesium ribbon, a dazzling white flame is observed. Yes. Explain why light is produced, why white powder is formed, and what is the type of reaction. How to answer these kind of questions? So to answer these kind of questions, we must have the knowledge of a kind of reaction called combustion reaction, which is the one of the types of main types of reaction. See, simple, no much logic in this type of reaction. A combustion reaction, just 2 or more reactants are combining, single product is formed. Simple. Generally, if you show the pattern of this combustion reaction, it will be A plus B is equals to AB. Here A and B are the 2 reactants, AB is the product. So 2 reactants are here, single product, so we call it as a combustion reaction. Now, here are the examples. The question raised in the earlier slide, a white powder added to water, then a milky white is formed. Usually, even the container becomes hot, that is, heat is produced there. Why the heat is produced? So as per the equation, you can say what is the white powder? Yes, of course, it is the calcium oxide or quick lime added to water and forms wet lime, that is calcium hydroxide. We wrote here heat is evolved. So if you look at the pattern, two reactants are here, two products, actually not. Heat is a form of energy, so don't treat it as a material product. It is a product which is in the form of energy only. So only single product. That is why this reaction comes under combustion reaction. So for the question we raised earlier, for this question, what is the type of reaction? This is a combustion reaction. What is the name of the white powder? That is calcium oxide, obviously. Now question comes here, reason for heat production. What's the reason for the production of heat? Usually the heat is produced or the energy is liberated in any reaction where formation of new bonds. When the new bonds are formed, see, both calcium oxide and water, both are combining, so new bond is formed between them. So they both together become stable. Since new bond is formed, the formation of new bond in the chemistry usually gives energy. That energy which comes out is in the form of heat, and because of that reason, usually this reaction is also called as exothermic reaction, which we are going to learn in the next parts. So if you answer this question, simply see the thing. This is a combustion reaction. In fact, since heat is produced, you can say this as even exothermic reaction. So that's why don't simply confine to a single answer. You have to add additional points if the question is addressing clearly. And of course, these are the other reactions which are examples for combustion. Now look at this question. During the manufacture of cement, limestone is heated in a kiln, that is a furnace, at a very high temperature. A gas is released and quick lime is obtained. Answer the following questions. What's the name of the reactant? See how beautiful the questions are. Write the balanced chemical equation. So he did not give you exact names. He gave you simply trivial names, that is common names. Write the balanced chemical equation. Identify the type of reaction. Why heat is necessary? That means you look here. Limestone is heated in a kiln. Heated in a kiln means we supplied heat to the limestone. And he's asking why heat is needed there. Now we are going to get contrary answer to the earlier question. Chalo, let's see. Silver chloride is kept in sunlight for several hours. Questions. What observation is seen? Why does it happen? Name the reaction. So if you look here, for addressing these kind of questions, we need to understand a reaction called decomposition reaction, which you have might already understood. Simple, quite opposite to the earlier reaction. In the earlier case, you look here, combustion reaction, multiple reactants, single product. Here, one compound breaks down into two or more simpler substances. That is, single reactant here, multiple products. In this reaction, in the earlier reaction, what we have done, making of bonds. Two reactants or three reactants combine to form a single product. So new bonds are formed. But see here, single reactant was broken down into simpler substances. That means we are breaking the bonds here. To break the bonds, we need energy here. So we have answered the last question in the earlier case, right? So what is the need of heating the compound? Because we need energy to break the bonds if we want to separate. For that, we are heating, means we are giving the heat as energy form. Okay, so now coming to the point, sir, can we break the compound just by heating, just by supplying the heat? Of course not. You can break the compounds even by supplying the electricity. You can break the compounds even by supplying the light. So based on what kind of energy are you giving to a compound to break it into simpler compounds or simpler substances? Based on that, decomposition reactions are of three types. So when you want to answer this question, what is the type of reaction here? You do not answer simply this is a decomposition. Of course it is a decomposition, but the decomposition happens upon heating. So when the decomposition reaction occurs by using the energy source heat, you can call that decomposition as thermal decomposition. So answer for the question is thermal decomposition. And for example, this is a very familiar example, hydrolysis of water or electrolysis of water. What is that? When you pass electricity through the water, automatically it splits into hydrogen gas and oxygen gas. So single reactant split into two products, so it is a decomposition, but the decomposition is achieved by supplying the heat in the form of electricity. So we call it as electrolytic decomposition. And look here, in the last case, silver chloride is kept in sunlight for several hours. What is the observation? Look here, the observation is simple. The silver chloride, it changes the color. Then automatically, what do you understand? We supplied sunlight, that is light energy, to silver chloride, and it was broken into silver and chlorine gas. This is also a decomposition, but exactly this is photolytic decomposition because we are giving the energy in the form of light. So decomposition reaction means simply single reactant split into multiple products, two or more than two. Where the splitting is happening, we need to supply the energy. So since we are giving the energy, maybe when you consider thermal decomposition, it comes under endothermic reaction. Yes, we are going to learn them in the next parts. So decomposition can be thermal decomposition, where the heat is supplied to break the bonds. Electrolytic decomposition, electricity is supplied to break the bonds. And photolytic decomposition, light, especially sunlight, is needed to break the bonds between the compounds. Yes. Most easiest question it looks like actually, but try to answer this question. 3 test tubes are there. In one test tube, zinc metal plus iron sulfate. In another, copper metal iron sulfate. In another test tube, iron metal plus copper sulfate solution. Predict the products in each reaction. Can you answer this question? You can pause the video and answer the question in the comment section. A student performs the following experiments. See, look at the experiments. Maybe look here, iron plus zinc sulfate, zinc plus iron sulfate, copper plus silver nitrate, silver plus copper sulfate. These are the experiment. What is the observation in each case? That is simple. Whether change in the color happens or something is deposited on the metal which we used. Those are the observations. You can answer these questions. So to answer these kind of questions, you might have got an idea. To answer this kind of questions, we need to understand a special kind of reaction called displacement reaction. Of course, The beauty in the main types of the reactions is the word itself clearly conveys what is exactly happening in the chemical reaction. Look here. Chalo. The displacement reaction is a reaction in which, simple, a more reactive element displaces less reactive element. Maybe you might have related to Coco or any particular game where one active player is replaced by maybe some injured or inactive player. The same happens here. Look at the pattern. A, it's a metal. Here BC is a compound. AC is the compound and B is the metal. So now, if you look at that equation, A is occupying the position of B. That means B was kicked out by A. Then definitely we might have understood one thing. A is the more reactive element, B is the less reactive element. Simple. The stronger pushes out the weaker. Obviously, more reactive element or metal usually wins the race or the competition. Sir, which is more reactive then? For that, yeah, you have to follow me to say something like here. Please stop calling me a zebra. I truly like her calling me super powerful giraffe. Just remember this mnemonic. Once again, I'll recall. Please stop calling me a zebra. I truly like her calling me a super powerful giraffe. In this, each term, the first alphabet is giving you the names of the elements, especially metals here. We arranged them in an order and we call this arrangement as reactivity series. So why? Because here we arranged the metals in the order of their reactivity. The topmost metal is highly reactive. The bottommost metal is least reactive, in fact inert, means lazy. It may not participate in any reaction generally. So from potassium to gold, the reactivity goes on decreasing. So in the reactivity series, topmost metal is highly reactive. That means as per this series, potassium is the most reactive metal according to the data which is enough to our grade 10. Now after sodium, after calcium, magnesium, aluminium, zinc, iron, tin, lead, hydrogen, copper, mercury, silver, platinum and gold. So these are the different metals which we usually see in our chemical reactions and equations. So just remember this order. So simplest point need to mind in this. Since we are talking about displacement reaction, any metal can displace all the other metals from their compounds which are below it. Now means potassium can displace any other metal. Look at the sodium. Sodium is the second metal. It can displace all the metals from the bottom, but it cannot displace the potassium. In the same way, calcium can displace all the metals below, but it cannot displace the sodium and potassium. In the same way, aluminium can displace all the metals below it, but it cannot displace the metals above it, that is magnesium, calcium, sodium and potassium. Aluminium cannot displace them. So now, to answer those questions, just very simple. See, look at the possibility. For example, look here, zinc, iron, which is at the top? Zinc is at the top. So that's why here zinc can displace the iron. So we get zinc sulfate plus iron. Look here, copper plus iron sulfate, which is at the top in the reactivity series. Look here, copper is here, Iron is here. Which is at the top? Iron. So iron can displace the copper, but copper cannot displace the iron. That's why in the earlier reaction, in this case, no reaction, because copper is less reactive than iron. It cannot displace iron from its compound. Whereas iron plus copper sulfate, yes, this is a familiar reaction for us. Iron can displace the copper. So this is the displacement reaction where it purely depends on the reactivity series to answer. Now coming to few other questions here. A colorless solution of silver nitrate is mixed with the sodium chloride solution. That is the activity. Now there are few questions related to the statement. State the observation. Name the precipitate formed. Identify the reaction. Why is it called a precipitation reaction? Of course, just by looking at the question, it looks easy because he is giving the hints in the question itself. Another question. Two transparent solutions produce a white insoluble solid. Explain why has a chemical reaction occurred? Which type of reaction is this? What is a precipitate? So it is a generalized question. To answer this kind of questions, definitely we need to understand another important type of reactions, that is double displacement reaction. Simple. Swapping of partners. An interesting hint in this swapping of partners, exchanging the partners. Just very simple. Look here, two compounds exchange their ions, partners, to form new compounds. If you look at the general pattern of the reaction, AB, imagine A and B is a pair, C and D is the pair. So simple. C got divorced with D and A got divorced with B. Now A married D and C married B. That's it. The partners are swapped, partners are exchanged. Achha, don't apply it to daily life. So in this, ions are exchanged between the compounds. That's why we call it as a double displacement reaction. In the double displacement reaction, based on the type of products, how the products are formed and how the reactants are, what kind of reactants are involved, based on that, we say one kind of reaction called precipitation reaction. So what is a precipitation reaction? We have seen it already. So simple. Look here, the earlier example that we have seen in the activity, last question. Silver nitrate solution added to sodium chloride solution. There he found silver chloride, means they said something is, what is the observation? A white precipitate was formed. Why the precipitate is formed? Actually, what is meant by precipitate? Simple. When two clear solutions are added to each other, silver nitrate solution added to sodium chloride solution, then one of the products is insoluble in water. That insoluble product settle down, separate from the mixture as a solid. It will settle down at the bottom. The solid which is insoluble and it settles at the bottom, and that settled at the bottom is called a precipitate. Of course, this is a double displacement reaction because partners are exchanged here. Ions are exchanged between the compounds. At the same time, one of the products is a precipitate. That's why we can call this reaction also as a precipitation reaction. A precipitation reaction is a kind of double displacement reaction, keep in mind. Now coming to another kind. Sir, when we add two transparent solutions to clear solutions, do we get precipitate always? Absolutely no. Look at this reaction, most familiar. Hydrochloric acid added with the sodium hydroxide we got sodium chloride. and water. So this is all these are aqueous, that is, of course, this is liquid water. Means the sodium chloride that is formed is also soluble in it, soluble in the mixture of the solution. That's why this is a double displacement reaction. But since the reactants that are participated here acid and base, acid is reacting with base to form salt and water, that's why you can call this reaction as neutralization reaction. So which is a kind of double displacement reaction. So double displacement reaction has two types of reactions, like as we said, precipitation reactions and neutralization reactions. Very important, keep in mind. Have a simple glance to distinguish between displacement and double displacement reaction, because some students might get confused. So simply look at that. Displacement, one element, look here, one element is participating, one compound, whereas two compounds are participating in the reaction. One element replaces another, two compounds exchange ions commonly. We need reactivity series whether the displacement reaction happens or not. We don't want any reactivity series because here the compounds are exchanging their ions to proceed the reaction. Yes. Now this is the short table where we need to understand about the different kind of reactions in the main types: combination reaction, decomposition reaction, displacement reaction, double displacement reaction. Chalo, that is okay. Now look something else. Oxidation. We have got another kind of reaction called here oxidation reaction. And also we got reduction reaction. Oxidation and reduction reactions can be defined in three ways, not simply in a one way. If you want to understand about oxidation, oxidation reaction can be defined based on the oxygen, based on the hydrogen, in fact based on the electrons. So to define oxidation or reduction, we use oxygen or hydrogen or even electrons. So then how? Simple shortcuts are here. When oxygen is added to something, suppose I got oxygen is added to me, then simply say that I have undergone oxidation. Sir, how to identify, sir? You can simply remember, when oxygen is added to me, the number of oxygens with me will be increased after the reaction. Just observe me before reaction and after reaction. If number of oxygens with me increased from before to after, yes, oxygen is added to me, so I have undergone oxidation. Suppose hydrogen is removed, so I am here. From me, someone took the hydrogen. I repeat, I am here. From me, hydrogen is taken by someone. That means I have lost the hydrogen. Then also, you can say that I have undergone oxidation. How can you predict easily? Yes, before reaction, after reaction. Count the number of hydrogens with me. If the number of hydrogens with me decreased, yes, I have undergone oxidation. So I have defined oxidation in two ways now, with respect to oxygen, with respect to hydrogen. Oxygen is added to me, I have undergone oxidation. Hydrogen removed from me, I have undergone oxidation. Now what else, sir? One more is there. Look here, loss of electron. I have lost electron in some other case, for example. Loss of electron is oxidation. Leo. Simple. Now I am the Leo. I lost electron. Sir, how to count that? Same, count the charge with me. If the charge reflects that I have lost electrons, means the charge increased, positive charge increased, then automatically say that I have undergone oxidation. So oxidation is defined in three ways: addition of oxygen, removal of hydrogen, in fact removal of electrons. This is the oxidation. So then what about reduction? Obviously opposite to the oxidation. Simple. If hydrogen is added to me, now I have changed my character. If hydrogen is added to me, the number of hydrogens increased with me before and after, then tell someone that I have undergone reduction. Hydrogen is added to me. Hydrogen is added to me, so I have undergone reduction. Suppose oxygen is removed from me. Someone took out the oxygen from me. How to say that? Number of oxygens with me decreased. So I have undergone reduction. Then what about the case of electrons? I have gained the electrons, for example. How to predict that electrons gained by me? Just simply, if the charge with me, usually positive charge I'm talking about, decreased, then automatically say that I have undergone reduction. Electrons gained by me, I have gained electrons. Leo usually sounds grrr. That means gain of electrons is called reduction. If I gain the electrons, I have undergone reduction. If I lost the electrons, I have undergone oxidation. So oxidation and reduction can be defined in three ways: with respect to oxygen, with respect to hydrogen, with respect to electrons. Now, an important main kind of reaction we have called redox reaction. People also call it as oxidation reduction reaction. What's happening here? Both oxidation and reduction happens in the same reaction. Let's see in detail. Before that, we have a simple question on the board. Try to answer it. A student heats copper oxide. This is the black copper oxide. With hydrogen gas, the hydrogen gas is proceeding into that. The black color of copper oxide changes into reddish brown. Copper, water is formed. Yes, he gave the reaction itself. So copper oxide was the reactant, one of the reactants. Of course, hydrogen gas is passed over it. It was black in color. Then what is he saying? He got the brown product, reddish brown product, that is copper. In fact, water is formed, maybe in the form of steam or vapors. Now the questions. Which substance is oxidized? Which substance is reduced? Identify the oxidizing and reducing agent. Once again, don't be hurry, don't even worry. Slowly and carefully listen. Very interesting, and once you have understood this, you can answer any kind of questions related to this topic. Let's see. To answer this question, first let us try to understand what is a redox reaction. We have an example here. With that example, let us try to understand. Okay, so zinc metal reacting with copper sulfate solution to give zinc sulfate and copper metal. Let us analyze this reaction first. I'll write it again. So zinc, the copper sulfate, the products are zinc sulfate and the copper metal. First of all, I want you to know this is a tricky topic. Why? Because as we have already told, oxidation and reduction can be defined based on 3 points: oxygen, hydrogen, and electrons. This is a topic mostly given based on the electrons. If the question or if the concept is given to you in terms of oxygen and hydrogen, it will be a little easy, might be. But when he asks you this kind of question in terms of electrons, you have to think about it. Just look deep into it. So for that, first, when you get this kind of equation ever, give oxidation number to metals especially, or elements or atoms. Let us give oxidation number itself here like valency commonly. What is the valency of zinc here? As you have studied in the grade 9, it is an individual element, atom. Individual atoms do not carry any positive or negative charge. The charge on them is 0. So oxidation number of the zinc in this is 0. Now in the same way, at product side, come to the product side. Copper is also in the form of element. So that is why its oxidation number also 0. Zinc from reactant side changed into product side like this. So zinc changed to zinc sulfate. Copper sulfate changed into copper, for example. Now let us find the valency or oxidation number of copper in the copper sulfate compound. From polyatomic ions, we know very well. See, for sulfate, its charge will be -2. We know it very well. To balance this -2, copper must carry +2 on it. So then only +2 -2 will be nullified and 0. Same way, coming to the sulfate, in the zinc sulfate carries -2, where the zinc must carry +2. Now look for the reaction. Zinc from 0 oxidation number changed to +2 oxidation number. Now tell me, oxidation number increased. Coming to the copper case, +2 was the oxidation number. Right side it has become 0. That means oxidation number decreases. This looks like when oxidation number increases 0 to +2. So keep in mind, increase in the oxidation number is oxidation. Copper sulfate here changing its oxidation number from +2 to 0. That means its oxidation number decreases. So we say that it has undergone reduction. We can confirm here also. So zinc losing its electrons and undergoing oxidation. The copper gaining the electrons and undergoing reduction. So in this reaction, both reduction and oxidation occur at a time. That's why this reaction is called as a redox reaction, as we mentioned. Now, from this reaction, how to identify oxidizing and reducing agent? That's very important. In a given redox reaction, what is oxidizing agent? What is reducing agent? That will be asked in many kind of questions. So let us take the example again here. The zinc, which is turning into zinc sulfate, the copper sulfate changing into copper. As we said earlier, this is oxidation reaction and this is the reduction reaction, right? Now in a simple way, which one is undergoing oxidation here? Zinc is undergoing oxidation. Which is undergoing reduction? Copper sulfate or copper is undergoing reduction. In this redox reaction, which is called as reducing agent and which is called as oxidizing agent. For that, we need a simple polarity. Look here, zinc losing the electrons. Zinc losing the electron. Since it is losing the electron, we say that it has undergone oxidation because we know Leo, loss of electron is oxidation. Chalo, zinc is undergoing oxidation and it's losing the electrons. Since it is losing the electrons lost by the zinc must be gained by someone. So the zinc which is losing its electrons is giving those 2 electrons to copper. Simply, zinc is losing the electrons, copper is gaining those 2 electrons. That means losing of electrons by the zinc happened in the presence of copper, since copper is gaining the electrons. So that oxidation of the zinc by losing the electrons has been done in the presence of copper sulfate. So that's why here copper sulfate is called as oxidizing agent. We can compare this in a simple way. Suppose here is a person, one more person is here. Just simple, we use this language especially in insurance policies. Just recollect that knowledge. Suppose this is the man who is taking the policy. He is taking some policy, insurance policy. To propose his insurance policy, one more person, that is maybe employee of that company or someone, act like an agent, right? So he is taking the policy under the presence of agent, right? So same way, so who is taking the insurance? This man, in the presence of whom? Another man. That another man is called agent. Same way, zinc is undergoing oxidation. By what process? By losing the electrons. Who is helping that process? Copper sulfate. So here copper sulfate is oxidizing agent. Why? Because it is taking the electrons from the zinc. So that's what mentions here. See, copper sulfate is the oxidizing agent there. What is it doing? It is accepting the electrons. From whom? From the zinc. Causing the oxidation. Oxidation of whom? Oxidation of the zinc. That is why it is called as oxidizing agent. But when you look at the oxidizing agent itself, it undergoes reduction. Why? Because it is gaining the electrons. So in a simple way, oxidizer, what I'm saying here, oxidizing agent oxidizes other but gets reduced. Simple shortcut. So here copper sulfate is the oxidizing agent. It is facilitating the oxidation of zinc, but itself it undergoes reduction. The same happens with the zinc as well. For example, copper sulfate is undergoing reduction by taking the electrons. Who is giving the electrons? Zinc is giving the electrons. And the zinc is undergoing what? Oxidation. And it is causing the reduction of copper sulfate by giving electrons to it. So here zinc is the reducing agent. So what finally says? Zinc is the reducing agent because it is causing the reduction of copper sulfate by giving the electrons to it. So reducing agent, in short, we call it as reducer, reduces others, but itself undergoes oxidation. So that's why zinc is undergoing oxidation. It is the reducing agent because it is causing the reduction of copper sulfate. Now, for example, in Another case, if you look at the another reaction here, methane gas burning in the presence of oxygen. Look at the reaction. When you compare the left to right, CH4 and it is CO2 here. So from here to here, carbon lost its hydrogen, gained oxygen. So two happen here. It is losing the hydrogen. In that way, it is oxidation process. In fact, when you look at right side, the carbon has gained oxygen. So based on the point of oxygen also, it is undergoing oxidation. Then obviously, look here, oxygen gas, right side is with hydrogen. That means oxygen gaining the hydrogen. So we say it is undergoing reduction. Yes. Now, which is undergoing oxidation? Methane. In the presence of whom? Oxygen. So, methane is undergoing oxidation in the presence of oxygen gas. So, here oxygen gas is the oxidizing agent. The oxygen is undergoing reduction in the presence of methane. That's why methane is the reducing agent here. So, simple point. Take another example which we have here. Hydrogen sulfide, sorry, hydrogen sulfide reacting with chlorine gas, forming the hydrochloric acid and sulfur. So from left to right, H2S and here is S. H2S lost the hydrogen. Hydrogen is removed from it. Removal of hydrogen is which process? Oxidation. Look, chlorine here, by the time reaching the product side, it has gained the hydrogen. That means it has undergone reduction. So in this redox reaction, H2S undergoes oxidation, chlorine undergoes reduction. Since chlorine is undergoing reduction, it must be oxidizing agent. H2S is undergoing oxidation, that's why it must be reducing agent. So always keep in mind the two shortcuts. A reducing agent or reducer reduces others, but itself it undergoes oxidation. An oxidizing agent oxidizes others, but itself it undergoes reduction. That is the shortest point trick you have to remember to answer any kind of question. Now, simple topic. As we have classified the chemical reactions into main types, now this is another classification where the reactions are classified based on the energy changes. Whether energy is absorbed or energy is released during a chemical reaction. Based on that, the chemical reactions are of two types. As we have seen on the board, one is exothermic reaction. If you look there, when the heat is released during any chemical reaction, usually it is called exothermic reaction, obviously. So if you look here, the reaction mixture and the surroundings. For example, I took some quicklime plus water. When you mix these two contents, if I touch the container, I will feel hot. The container becomes hot. Why the container becomes hot? Because heat is liberated from this reaction mixture to surroundings. Since heat is produced, liberated, we felt the container has become hot. So that is the simplest principle. From reaction mixture, if heat is sent to surroundings, that is called a exothermic reaction. Better examples: burning of fuels, the respiration process, slaking of lime, as we have seen there. These are the best examples for exothermic reactions, most common examples for exothermic reactions. If we recall why the heat is generated, why the heat is produced, why the energy is released, in an exothermic reaction? It's very simple. The reaction in which formation of new bonds when the formation of new bonds take place, automatically that formation of new bonds releases energy. Always keep in mind, formation of new bonds releases the energy. So exothermic reactions liberate heat. Due to that only we call them as exothermic reactions. Now coming to the point, endothermic reaction. Here heat energy is absorbed. Here the flow of heat is reverse. The heat flows from surroundings to reaction because we need to give energy to initiate the reaction. In fact, to proceed the reaction. That's what we talk about endothermic. See, for example, thermal decomposition of calcium carbonate, photosynthesis, these are the examples of endothermic reactions. As we mentioned, endothermic reactions are involved mostly decomposition. Decomposition means, yes, breaking of bonds. When the bonds are broken, automatically they need energy. To break the bonds, we need the energy. Automatically, if we want to decompose something, we need to supply energy to it to break the bonds. So keep in mind, wherever the breaking of bonds is happening, automatically there we need energy to break them. Some of the common examples or kind of reactions which come under exothermic and which come under endothermic. Look there, burning or combustion reactions, neutralization, that is when an acid reacts with a base or acidic substance reacts with the basic substance, automatically we call that as a neutralization reaction. The neutralization reaction is an example of exothermic reaction because heat is produced there. Respiration, obviously, we can experience it by keeping our hand near the nose. As we said, any reaction where the new bond formation is happening, definitely that comes under exothermic reaction as heat is or energy is released there. One more important point you need to remember here. In exothermic reactions, as we said, heat is released, it will be negative in form. Products have less energy than reactants. In chemistry, we need to remember one point. Substances with high energy, when the substances have high energy with them, they will have less stability. Vice versa. If the energy with the substances is low, less, their stability will be more. So thing is, when a reaction is happening, for example, reactants to products, if heat is generated, if energy is released, that means the energy of the products must be less than the energy of the reactants. So means that that reaction is happening easily, actually, almost spontaneously. It's happening on its own. That's why the energy of the reactants is more, the energy of the products is less. Means products are more stable compared to reactants. That's why the reaction happens easily. So energy is released, which come under exothermic reaction. And when it comes to endothermic, vice versa. The products have more energy than reactants. That means products are unstable, are less stable compared to reactants. Reactants are more stable, but the reaction is happening because heat is being supplied. That is why the endothermic reactions so happening and by taking the heat or any kind of energy. Usually the decomposition reactions, electrolysis, photosynthesis, these are the best examples for endothermic reactions. So keep in mind, once again recalling, the breaking of bonds requires energy. So supplying the energy make the equation as endothermic. Formation of bonds releases the energy and making the reaction as exothermic reaction. Simple point. Yes. Here comes another question. An iron bridge near the sea rusts faster than an iron bridge in a dry desert. The most appropriate reason is more sunlight near the sea. Is actually correct answer? Actually, no. Seawater contains moisture and dissolved salts. Iron is heavier near the sea. Not true. Desert air contains more oxygen. Obviously not true. So this is the correct option. A student says galvanization works because zinc never corrodes. Yeah, this is the most important question. Try to answer by pausing the video. How many of you think that zinc never corrodes? Means since we are using the zinc metal to give coating on the iron articles by the process called galvanization, many people think that zinc does not form rust. I mean, zinc does not have corrosion. But it is not at all true. Why? Let us try to understand by the next one. So here, another interesting question. A man wants to protect an iron gate from rusting by the process of galvanization. Which type of metal should be used for coating the iron? See, first option, a metal less reactive than iron, a metal more reactive than iron. Which metal should be used? So if you are able to answer the first question, I mean this third question, you will be able to answer the second question as well. So before we answer those questions, first of all, let's see what is corrosion. Definitely, metals upon reacting with oxygen, moisture, acids, and other harsh chemicals, they undergo usually deterioration. That is, their oxides are formed. Suppose here sulfide is formed, maybe some other compounds might be formed instead of being pure. That automatically destroys the properties of the metals, like we discussed maybe in our earlier classes, like the conductivity, ductility, malleability, sonority, lustrous nature. All those good qualities of the metals will be lost when they form rust on them, when they undergo corrosion. So how that corrosion happens actually? Simple. There are two mandatory conditions required for the corrosion or the rusting of metals. One is oxygen, another one is moisture. These two are must needed for the corrosion to happen. If any of these two is missing, automatically the corrosion never happens. That's why in the earlier question where we have seen the rusting happens for a steel bridge easily near the sea, because there we will have more humidity as well as some salts. In fact, definitely the atmospheric air contains oxygen. Due to the presence of all these, usually the rusting happens, the corrosion happens faster. So simply you can remember the rust means reaction with oxygen under moist conditions. Of course, it will not happen rapidly, fast. It's a slow process. Definitely turns the metal into oxide. So see here, how to avoid that. Yeah, before we talk about how to avoid that rusting, how to prevent that rusting, let's see the question of galvanization. There are two metals we have, zinc and iron. What was the question? Zinc is used for galvanization of iron. Does it mean that zinc does not form rust? Means zinc does not corrode. Actually, if we recall the reactivity series, zinc is more reactive than iron. If it is more reactive, why it does not form rust? Definitely it corrodes faster than iron. But what's the issue here? But then why are we using, sir? Simple. Suppose this is an iron rod, a bar of iron. A zinc coating has been done here, for example. When the zinc coating is done, what happens, the zinc which is at the surface immediately combines with oxygen and moisture and forms rust. So once the zinc corrodes, once zinc form rust, automatically a protective layer, as we have seen the red color, a protective layer is formed by the zinc Yes, like an armor. Now, protective layer is formed by the zinc. So, this protective layer is preventing the oxygen and moisture reaching from the iron, because iron is inside. Already there is a protective layer. So, water and oxygen cannot come in contact with the iron. So, iron cannot form the rust and it will stay strong. That is the principle involved in the galvanization. So, now for the third question, what will be your answer? A metal less reactive than iron or a metal more reactive than iron? Definitely, a metal more reactive than iron will be the best choice for galvanization process to avoid the rusting of iron. So definitely, since the corrosion destroys the all good qualities of the metals, we have to prevent the corrosion, and for that purpose we have various methods. One of those is painting, even greasing and oiling, as we have seen the galvanization, electroplating. So all these are the techniques where we are forming a thin layer over the metals, and that thin layer or the protective layer prevents the corrosion by avoiding the contact of oxygen and moisture with the metals. An important process called alloying is also a method to prevent the metals from rusting. For example, look here, steel, that is the mixture of iron and carbon. So usually if a metal is mixed with another metal or metals or non-metals, then that mixture of metal and other substances is called alloy. When we go with this alloying process, the strength of the mixture will be very high compared to the individual metal, pure metal, and also the rusting and that is corrosion also be avoided, and that strength of the metal and the qualities of the metal will be lost for more time, so that is the best method for avoiding the corrosion. Another interesting question here. Chalo, many people like this, but if you compare both the pictures, you might have understood simple thing. So in the first picture, the boy is really disappointed because the chips have become stale and unpleasant in taste and smell, where the chips packet was open. This is a picture which is showing you the chips packets were fresh because they were sealed properly, closed properly. What's the reason for the unpleasant taste, unpleasant smell? Why? I mean, what kind of gas is filled in that chips packets, etc.? To answer this question, we need to understand a concept called rancidity. What is rancidity? Simple. The foods which contain fats and oils, that is solid form or liquid form fats and oils, usually when they are exposed to atmospheric air, I mean oxygen, the fats and oils undergo oxidation. That oxidation results unpleasant smell and taste of that food item, whether it is chips, pickles, or any fried items, etc. So that spoiling of food which contain fats and oils, especially due to oxidation, is called rancidity. The cause for the rancidity is oxygen in the air, as we said, reacts with the fats and oils. Obviously, the heat, light, and moisture speed up this process. Definitely, when sufficient heat, sufficient light, even moisture, that is water, present there, automatically the rancidity, the oxidation of the food becomes even faster to spoil it. What are the day-to-day life examples that we witness? simple as we have seen in the earlier case, the chips packet case, and some kind of, see here mentioned about the butter, and especially the fried food items easily get spoiled like biryani, etc., since because of the oxidation process. So how to prevent it, and what's the reason, what's the need to prevent it? Definitely to avoid the spoiling of food, right? To store them for long time as much as possible, especially the food items like pickles, etc. So look here, how to prevent that? See, as we have seen, what is the cause for the rancidity or oxidation of food? Oxygen, heat, light, moisture. These are the causes for the oxidation of food. If you stop those causes, if you stop them, automatically the oxidation of food will be stopped, so that we are going to prevent the rancidity. For that, what to do? Storing the food in airtight containers, obviously. Keeping the food in the refrigerator so that we are avoiding the heat, we are maintaining the low temperatures, which slow the process of oxidation as much as possible. Vacuum pumping, definitely, which evacuates the air, I mean oxygen. Nitrogen flushing, if we use the nitrogen, that evacuates the oxygen gas. By removing the oxygen, if you fill the food packets, especially like chips packets, with nitrogen gas, nitrogen cannot react with these oils and fats, so no reaction happens there. The chips will be fresh inside the packet. Some kind of chemicals, antioxidants, means which avoid, which prevent the oxidation of the food. Some kind of chemicals like butylated hydroxyanisole, butylated hydroxytoluene. These are the compounds which avoid the, which prevent the oxidation of the food, and we are calling them as antioxidants. By them, we can prevent the rancidity and store the food for more number of days. So by this, we have concluded the chapter chemical reactions and equations. If anybody still have doubts, you can mention those doubts in the comment section.